So far, we have discussed the topic average velocity and average speed, right? So we did 10 questions out of it. I have given you almost the coverage of all possible questions, which I could frame in keeping the number constant as 10. See, the more you practice, the more variety of questions you get. But I would say this is the bare minimum to know these many problems. Having said so, let us now move to the next topic, which is instantaneous velocity. So those students who have attended the theory lectures, you would have got now a clear idea about the difference between average velocity and instantaneous velocity. Okay, so this is the first question. It goes like this: a particle moves along a straight line OX at a time t. The distance x is given by 20 plus 6t square minus tq. How long would the particle travel before its acceleration becomes zero is the question. See, there's one thing that you need to understand here, which I would say is the relationship between differentiation of distance with respect to time. See, what is given here? X is given, right? So when you differentiate x with respect to time, what do you get? You get velocity. When you differentiate velocity with respect to time, or in other words, when you differentiate velocity, which is basically dx by dt, what do you get? You get the next term, which is acceleration, right? So acceleration, in other words, is nothing but the second derivative of distance, right? So what is acceleration? Acceleration is the second derivative of, I beg your pardon, second derivative of not distance, it is displacement, right? In which case, we can write that if acceleration becomes zero, then the second derivative of distance also becomes zero. Now, what is second derivative of distance? It can be written as d by dt of x is equal to 0, which further goes like this: d by dt of, what is dx by dt? Is d by dt of x. What is x? X is given as the equation 20 plus 6t square minus t cube, and this is equal to 0, right? So let us now differentiate. So we'll get d by dt of, what is d by dt of 20? It is 0. D by dt of 6t square is 12t minus d by dt of t cube is 3t square. Now, if you have any doubt in using differentiation and integration, please don't feel, that shouldn't be a factor for demotivating you. It is okay. It is okay that you don't know it for the time being. I will give the link for the description. I will give the link in the description for the video series. I uploaded 10 videos which will include all the applications of differentiation, integration, and vectors in physics. Okay, you can go through them and then come back to this question. So now what will be the second derivative? Will be d by dt of this. This will be equal to 12 into, okay, let me just write down the step in detail, minus 3 into d by dt of t square, which is equal to 0. Now what is 12 into d by dt of t? It is 12 into 1 minus 3 into 2 into 2 raised to 2 minus 1 is equal to 0. So it becomes 12 minus 60 is equal to 0, which implies 12 is equal to 60, and therefore t is equal to 2 seconds, right? So the object will reach, so the acceleration would become 0. So acceleration is equal to 0 at time is equal to 2 seconds. Now, what is the question? Is the question to find when is the acceleration becoming 0? No, it is asking how long would the particle travels before the acceleration becomes 0. Okay, let us now try to understand how we'll do that. See, the given equation is x is equal to 20 plus 6t square minus t cube. It is also given that when acceleration is equal to 0, The time is in 2 seconds, right? Now, if you try to understand this using a diagram, if suppose the body is moving from A to B at time t is equal to 0 to t is equal to 2 seconds, we can say that at this point the acceleration was 0, right? So, acceleration is equal to 0 when t is equal to 2, or when the object has covered the distance AB, right? Now we can say that distance AB is what we need to find. So distance AB is basically equal to distance covered at time t is equal to 2 seconds minus distance covered at time is equal to 0 seconds. So basically the distance time relationship is being evaluated at two different points. Now, what is distance time relation? What is distance at t is equal to? It is 20 plus 6t square minus t cube at t is equal to 2 minus 20 plus 6t square minus t cube at t is equal to 0, right? So this is equal to 20 plus 6 into 2 square minus 2 cube minus 20 plus 6 into 0 square minus 0 cube, which basically is equal to 20 plus, what is 6 into 2 square is 24 minus 8 minus 20, right? So this will give you 20 plus 24 is 44, 44 minus 28, which is basically equal to 16. So the required distance is equal to 16 meters, in which case the correct option is option A. A particle moves along x-axis in such a way that its coordinates x varies with time t according to the expression x is equal to 5 minus 3t plus 4t square. Its initial velocity is. Pretty straightforward question. What is given us here? Basically, what's given us the displacement time relation, right? So the displacement time relation is given here. What is it given as? This is given as x is equal to 5 minus 3t plus 4t square. Now, what is velocity is equal to? Velocity is equal to dx by dt or d by dt of x, which is equal to d by dt of 5 minus 3t plus 4t square, which is equal to minus 3 into, okay, let me, for those people who have not covered the basic differentiation chapter, let me write this in each and every step. So we have d by dt of 5 minus d by dt of 3t plus d by dt of 4t square is further equal to derivative of constant is 0 minus this will be 3 into d by dt of t plus 4 into d by dt of t square. So this will be equal to 0 minus 3 plus 4 into d by dt of t square is 2t. How? It is 2 into t raised to 2 minus 1. So this we get it as 8t minus 3, right? So the velocity is given by 8t minus 3. Now, what is the question? Its initial velocity is, right? So, velocity initial would be obtained when velocity is at t is equal to 0, which means we'll get it as 8 into 0 minus 3, which is equal to minus 3 meter per second. Thus, the correct answer would be option B, minus 3 meter per second. The velocity of a particle v is equal to at plus bt square, where a and b are constants. Then the distance traveled by the body between 1 second and 2 seconds is. Okay. Now, this is a very straightforward question, but an application of differentiation. I'm sorry, application of integration. So let's see how to do this question. So first, let us write down what is given in the question. The question says that velocity is equal to, right? So velocity is given, which is equal to at plus bt square. Now, what are we asked to find out? We've been asked to find out the distance, right? Well, actually, it should be the displacement because velocity is set. So, how do we relate velocity and displacement? Guys, what is displacement? Sorry, what is velocity in terms of displacement? Is the rate of change of displacement, right? So, V is equal to ds by dt is basically equal to what? At plus bt square. Now, if ds by dt is equal to at plus b square, what is ds is equal to? ds is equal to at plus bt square the whole times dt, right? Now, this is in the variable separable form. This equation is in the variable variable separable variable separable form. And what is the benefit when the equation in the variable separable form? It can thus be integrated and can be integrated, right? So what we're going to do is we're going to integrate this equation. So we can write integral ds is equal to at plus bt square the whole times dt. Wait, let me just see, is it mentioned as x is equal to? No. Right. Okay. Now, if this is the case, when how will the integral vary here? Guys, see, what is the question being asked? The question is asked to find the distance traveled between 1 second and between 2 seconds, right? So 1 and 2 seconds is the limit. Now, it's very obvious that the limit of the time would be here 1 to 2, and for ds it will be 0 to s. Now, if you integrate 0 to d, also integral of ds, integral of, okay, let me just write down that step also. Integral of ds is basically integral of 1 ds, and this will be equal to a into integral of 1 to 2 t dt plus b into integral of 1 to 2 t square dt, right? Moving on further, this integral of 1 ds is s, so s varying from 0 to s, which is equal to a into integral of t is t square by 2, the whole varying from limit 1 to 2, and b into t square integral is t cube by 3, limit varying from 1 to 2. So s minus 0, upper limit minus lower limit is s minus 0. What do we have here? A into 2 square by 2 minus 1 square by 2 plus b into 2 cube by 3 minus 1 cube by 3. Okay. Moving on further, s minus 0 is equal to s. So this we get as a into 4 minus 1 by 2 plus b into 8 minus 1 by 3. Therefore, s will be equal to 3a by 2 plus 7b by 3. So this is the required final answer. Okay. So it was a pretty straightforward question, I would say. But yes, application of integration, that too application of definite integration, we need to understand that the upper and the lower limit will be given by the time that is given in the question. Okay. The velocity time relation of an object starting from rest is given by v is equal to 3t. When v is in meter per second and t in seconds, the distance traversed in 3 seconds is. Okay. So very good question. Again, a direct application of integration. So let's start solving this question by writing down the given details. What is given? It is given that v is equal to 3t, right? What is v? V is velocity. Now, what is velocity? Velocity is rate of change of displacement. So we have dx by dt, in which case v can be replaced by dx by dt, which is equal to 3t, which further leads to dx is equal to 3t dt. And since this is in the variable separable form, this can be integrated on both sides, right? Now, if you have observed the previous problem, I have very clearly stated the logic of inferring the limits. X will vary from 0 to x, and limit here is asked to find distance traveled in 3 seconds. So we'll have to integrate it from 0 to 3. Now, what is integral dx? It is x. So x varying from 0 to x times what is integral 3t dt? It is t square. Okay, it is 3 into t square by 2, the whole varying from 0 to 3. So this will be equal, this will further be equal to 3 into 3 square by 2 minus 0 square by 2, which is basically 3 into 9 by 2 or 27 by 2. So 27 by 2 will basically give you the answer 13.5 meters. So the correct option here is option C. A particle moves along a straight line OX. At a time t in seconds, the distance of the particle from O is given by x is equal to 40 plus 12t minus t cube. How long would the particle travel before coming to rest? Okay, it's a very good question. I would say this is a typical application of integration and differentiation again. So let's start solving this. Okay, so what is given? Given that x is equal to, right, 40 plus 12t minus t cube. So what I've been asked to find out, we have been asked to find out how long would the particle travel before coming to rest. So it goes like this. When the body is at rest, or let us say when the body comes to rest, what can we say? We can say that velocity would be equal to 0, right? So the velocity would be equal to 0. Now, how will the velocity be equal to 0? Because we know that when the rate of change of displacement is equal to 0, velocity is equal to 0, which otherwise means that d by dt of 40 plus 12t minus t cube is equal to 0, right? So what will this be equal to? This will be equal to 12 minus 3t square is equal to 0, which means 12 is equal to 3t square, which implies t square is equal to 4 and t is equal to plus or minus 2, since time is always in the, okay, t is equal to negative 2 doesn't make sense at all, right? So t is equal to 2 is, t is equal to 2 seconds is what we need. Now, what's important to understand is that the question is not asking you to find out when will the body be at rest. The question is asking how long would the particle travel before coming to rest, which means that we need to find out the distance traveled, distance traveled from 0 to 2 seconds. Now, how will we do that? Let's try finding it out. See, what is given in the question? The question is given, the question says that x is equal to 40 plus 12t minus t cube, right? Now, how can we write velocity as? See, velocity is basically dx by dt, right? So what is dx by dt? Dx by dt is 12 minus 3t square. Now what is dx in this, which case dx is equal to 12 minus 3t square times dt. This is again in the variable separable form and thus can be integrated from limit 0 to x will vary from 0 to x, and limit 12 minus 3t square will vary from 0 to the so-called determined time, which is basically 2 seconds, right? Now If we integrate this, what do we get? We get 12 into t varying from 0 to 2 minus 3 times t cube by 3, that will set it separately, varying from 0 to 2. So this will simplify as 12 into 2 minus 0 minus 2 cube minus 0 cube, which is equal to 12 into 2 is 24 minus 2 cube is 8. So 24 minus 8 is 16 meter, and therefore the correct option is option A. A particle position as a function of time is described as y is equal to dt square plus 6t minus 4. What is the average velocity of the particle from t is equal to 0 to t is equal to 3 seconds? Okay, so what would be the way to do this question? See, we know that average velocity, right? The average velocity is equal to the total displacement by the total time taken, right? Now, what is total displacement? I would say the final position minus the initial position by the time taken. Now, what is the given position? The position is given as y is equal to 2t square plus 6t minus 4. Now, what would be y is at t is equal to 0? Or rather, what would be the initial position? The initial position would be y at t is equal to 0, that is basically equal to 2 into 0 square plus 6 into 0 minus 4, which is equal to minus 4, right? Now, what is the final position? The final position is given as y at t is equal to, the question says 3 seconds, so y is t is equal to 3, which is equal to 2 into 3 square plus 6 into 3 minus 4, which is equal to 3 squares are 9, 9 twos are 18, 18 plus 18 minus 4. So that is basically 36 minus 4, which is equal to 32. Right? Now, let us now apply this into the previous formula. So now we can say that average velocity is now equal to final position, that is 32, minus initial position, that is minus 4, the whole upon 3 minus 0, right, which is equal to 32 plus 4 by 3, which is basically equal to 36 by 3, that is 12 meter per second. So the average velocity is, is 12 meter per. Displacement of a particle moving in one dimension under the action of a constant force is related to time by the equation t is equal to root x plus c, where x is in meter and t is in seconds. Find the displacement of the particle when the velocity is 0. Okay, so very good question. It's a bit good because it's a bit different from the questions we're doing so far. So we've been given that time is equal to root x plus 6, right? Which implies that t minus 6 is equal to root x. Now, if you square, let me mark this as equation number 1. And if I say squaring equation 1 on both sides, what do we get? T minus 6 the whole square is equal to root x the whole square. T minus 6 the whole square is t square t square plus 36 minus 12t is equal to x, right? So we basically have the equation x is equal to x is equal to plus 36 minus 12t. Now, if this is x, what is dx by dt? Dx by dt will be equal to d by dt of t square plus d by dt of 36 minus 12 into t by dt of t. What is dx by dt? Dx by dt is velocity, that is v. Derivative of 2 square is 2t plus derivative of 36 is 0 minus 12 into 1. which means velocities is equal to 2t minus 12. Now, what has been asked in the question? The displacement, the velocity is equal to 0. What is asked in the question? The displacement when the velocity is equal to 0. So, if velocity is equal to 0, then we can say that 2t minus 12 is equal to 0, in which case 2t is equal to 12 and then t is equal to 6 seconds. Now, if t is equal to 6 seconds, what is x is equal to? X was given as x was given as t square plus 36 minus 12t. Now, when t is equal to 6 seconds, what would be x equal to? X would be 6 square plus 36 minus 12 into 6, which is equal to 36 plus 36 36 plus 36 minus 72, which will be equal to 72 minus 72, that is x is equal to 0, in which case the displacement is equal to 0, and which further means that has the object has reached the initial position back in the motion. So the correct option here would be option D, which is 0. The velocity of the particle at any time t is given by v is equal to t into 3 minus t meter per second. At what time is its velocity maximum? Okay, see, so before we go into the solution, let me just try to give a graphical interpretation of the concept here. See, let us assume we have a graph here which is drawn like this with the y-axis and the x-axis, and say this is the curve. Okay, now let us consider these 2 points, point A and say point B. If you draw a tangent at point B as well as point A, you will observe two things: that the tangent at A is basically parallel to the parallel to the x-axis. Okay, now what is the concept that we are trying to discuss here? See, the made by the angle made by the tangent with the positive x-axis. Now, tan of the angle made by the tangent at that point with the positive x-axis is what we call as slope. In which case, at B, what is slope? Slope is basically equal to tan of the angle made by the tangent with the x-axis. This is the tangent, and the angle, well, I have to be a bit more correct here because it looks slightly inclined. I hope the concept is clear, that I'm trying to say that this line is basically more parallel. Okay, so if, since the x-axis is also inclined, there's no point in redrawing this. So assume that this line is basically parallel to x-axis. Okay, so the representation is not important, the concept is important. Now, if this is the tangent, this is x-axis, what is the angle between these two? The angle between these two is 0 degree. Now, what is tan 0? Tan 0 is 0, which means at B, slope is 0, right? Now, what is slope? Slope here is basically change in y-axis with respect to change in x-axis. So this slope is now equal to 0, right? Now, try and come to this question. See, if instead of y and x, if we have here v and t, what can we say? We can say that dv by dt is equal to 0. Now, the value was slowly increasing. It came to a maximum at A, right? So when there is maximum, the tangent at that point will be parallel, and therefore the slope will be equal to 0. So when the velocity is maximum, so when the y-axis is represented by velocity, when it is maximum, the slope at this point will be equal to 0. The slope at this point A, and for that matter, slope at this point B will basically be the change in y-axis with respect to change in time. Or in other words, this is basically time rate of velocity should be equal to 0. Now, what is time rate of velocity? Is d by dt of what is velocity given as 2t into 3 minus t, and this should be equal to 0. Now, what is dt? What is d by dt of 2 into 3 minus t? Is d by dt of 6t minus 2t square is equal to 0. What is d by dt of 6t? It is 6. What is d by dt of 2t square? It is 4t, right? 4t to the power 2 minus 1, that is 1. Now, if this is equal to 0, we can say that t is equal to 3 by 2. Okay, so instead of trying to just memorize that dy by dt is equal to 0, you should actually understand that how did this maximum velocity get related to the graph, and how did this du by dt becomes 0. Position of a particle with respect to time t along the x-axis is given by x is equal to 9t square minus t cube. What will be the position of this particle when it achieves maximum speed? Okay, well, I just have to continue the question because we have already discussed the graphical understanding about this. But yet, let me just try to make it one more time clear to you. See, distance when with respect to time, when differentiated, gives velocity. When velocity is differentiated with respect to time, what do we get? We get acceleration, right? Now, we've been asked to find out the position of this particle when it achieves maximum speed, right? So when we are finding maximum speed, we should understand that for maximum speed, we need to find out the VT relation first, right? It is in this VT relation. Say, for example, now this is V and T. We have a graph. At this point, there's a maximum. The velocity, the slope is equal to 0, right? The slope is equal to 0. So all of this will be based on the VT relation. In this VT relation, what will be slope? Slope will be equal to dV by dt, and then dV by dt will be equal to 0, right? For those students who haven't okay, for the students who haven't gone who don't get the idea of this concept clear, please go to the next video of the previous video of the playlist. Make sure that you understand this concept well and then come back. Okay, for others, see, if we have vt graph at the maximum point, the slope is equal to 0, the dv by dt has to be equal to 0. Only then the maximum speed is obtained. Now, in this case, what we need to understand is, if the speed is maximum, slope is 0. That is something we know. But are we given the VT relation? No, we have been given the time distance displacement time relation. If you differentiate this, what do you get? We get V, which is basically time rate of distance, as 18t minus 3t square. Now, can you equate this as 0? No, you can't do this. Why can't you do this? Because it is only the velocity relation we have obtained. Now we need to find out the time rate of this, which means dv by dt is what we need to find out. So what is dv by dt? Dv by dt is 18 minus 60. Now, if dv by dt is equal to 0, what can we say further? We can say that 18 minus 60 is equal to 0, which implies 18 is equal to 60, and then t is equal to 3 seconds. Are we done with the solution? No. Why? Because we've been asked to find out the position of the particle at t is equal to 3 seconds. Now, what is the position time relation? It is x is equal to 9t square minus t cube. So, x at t is equal to 3 seconds will be equal to 9 into 3 square minus 3 cube, which is basically equal to 9 into 9 minus 27. So we have 81 minus 27, which is basically 54 meters. So the correct answer would be option A, 54. Okay, so this will be the next question. The motion of a particle is described by x is equal to x0 into 1 minus e to the power minus kt. What was the velocity when the particle starts? Okay, it's very simple question. So what is given? Given is displacement time relation, that is x is equal to x0 times 1 minus e to the power minus kt, right? Now, what is velocity? Velocity is rate of change of displacement, which means we need to find the rate of change of x0 minus x0 into e to the power minus kt. Now, if we if we differentiate this further, what do we get? We get d by dt of x. Okay, let me write on that step. To d by dt of x0 minus d by dt of x0 into e to the power minus kt. See, x0 is basically a constant, in which case derivative of constant is 0, and in second term constant can be put outside, so we get x0 into d by dt of e to the power minus kt. Now, this basically means that velocity is equal to minus x raised x0 into what is the derivative of e raised to minus kt? It is basically minus k into e raised to minus kt, right? So what is v? V is basically k into x0 times e to the power minus kt. What is the question? The question is not to find out the velocity time relation, right? So this is basically the velocity time relation. What are we asked to find out? Velocity at when the position when the particle starts. So velocity at the particle starts is given by v at t is equal to 0, which is basically k into x0 into e raised to minus k into 0. E to the power 0 is 1. So what do we get the answer as? We get it as v is equal to k into x0. So the correct option here would be option